Hello everyone. So this is the video for number 1 through 23 on your final review for semester 2. Okay, so on number 1, so the goal of this problem is to get your bases to be equal. Okay, so one way to do that is to think about how can you rewrite the number 32. Okay, I don't want to change it, I just want to rewrite it. So I know that 2 to the 5th power is 32, and then that whole thing is getting raised to the radical 3. And then I'm multiplying that by 16, but 16 is also 2 to the 4th, and I'm raising that to the power of radical 2. Now remember from before, if you have a power to another power, you're going to multiply. So this is 2 to the 5 square root of 3 times 2 to the, if you multiply these, you get 4 square root of 2. Now remember from a long time ago, algebra even, right? If you had something like x squared times x to the 4th, that was actually equal to x to the 6th. And why is that? It's because when you multiply two terms with the same base, you just add their exponents. Same idea here. I'm multiplying two terms with the same base, so I'm just going to add their exponents. So it's going to be 2 to the, oops, I made a mistake already, 5, no I didn't, square root of 3 plus 4 square root of 2. And you guys notice on this one, there's not really much that I can do because the square root of 3 and the square root of 2 are different, so I can't actually add them together. Now on number 2, same idea. Let's change this times to like a dot. It just looks easier. Okay, so let's get these bases to be the same again. I'm not liking this gray color. I'll change it in a second. So 8 is 2 to the 3rd, and I'm raising that to the 2 square root of 3 power, and then I'm multiplying that by 4, which is 2 squared, and I'm raising that to the square root of 3 power. Again, power to power, we multiply. So this is 2 to the 6 square root of 3 times power to power, we multiply 2 to the 2 square root of 3. And again, using this little rule above that we just reviewed, okay, if you have two bases that are the same and you're multiplying, then you just add the exponent. So this is going to be 2 to the 6 square root of 3 plus 2 square root of 3. Now something interesting about this one, I can actually add these guys together because they both have a square root of 3. So that would equal 2 to the 8 square root of 3. Okay, and there you have that. All right, number 3, change to exponential form. There's two ways to do it. I will show you both. So one way you can do it is take this little base and then just do a little circle thing. Okay, I think 2 of my classes like that way. So you go little base, and then you raise that to the 3rd power, equals, and then it equals whatever that number is, which is 125. And the nice thing about this is that you can actually check your answer. Is 5 to the 3rd 125? If it's not, you did it wrong. Okay, now another way to do it, I'll show you on example 4, and you can pick whichever way you want to do. Take the little base, and then give that base to both sides of your equation. So I'm going to give this a base 10, and I'm going to give this a base 10. Now, if your big base and your little base are the same, these guys cancel out. So what are you left with? 0.001 equals 10 to the negative 3. You guys, again, that's correct. 10 to the negative 3 is 1 over 10 to the 3rd, which is 0.001. So either way, I think period 3 liked this way, and I think period 0 liked this way. So I don't care whichever way you do. All right, 5 through 10 solving. So this is the one where you're going to need a calculator. So pull out your calculators. So on number 5, we're going to go ahead and take the log of both sides. So we're going to have log of 6 to the x plus 2 equals the log of 17.2. Okay, and on this one, remember we call them little birdies. So we're going to take these little birdies, this little guy right here, the x plus 2, and we're going to drop it down in front of the logarithm. So it's going to become x plus 2 times log of 6 equals the log of 17.2. And the reason why we're bringing that exponent down is so that we can actually have like a regular linear function that we can solve. Okay, so solving for x, let's divide both sides by the log of 6. Divide by the log of 6. And I'm going to get x plus 2 equals. And at this point, if you'd like to plug that into your calculator, that's fine. So I'm going to go ahead and plug it in. So I've got the log of 17.2 divided by the log of 6. Hey, if you're doing this with me, actually plug it into your calculator and make sure you're getting the same answer as me. So this ended up being 1.5877. And then to solve for x, I'm just going to go ahead and subtract 2. You can do that on your calculator. Just subtract 2 from the answer you already have in there, and you get that x is negative 0.4122. All right? Hey, 3 decimal places should be fine on this, by the way. All right? Number 6, let me do that in a different color so that it pops a little bit. So on this one, it's same idea. I'm going to take the log of both sides. So I have the log of 8.2 to the n minus 3 equals the log of 42.5. Okay, take that little n minus 3, bring it down. So you get n minus 3 times the log of 8.2 equals the log of 42.5. And you guys, same idea as number 5. Divide both sides by log of 8.2. Divide by log of 8.2. And then we get n minus 3 equals, let's plug that into the calculator. So I have log of 42.5 divided by the log of 8.2. And for this one, I got 1.7819. And if I add 3 to both sides, this one I can actually do in my head. It's not so bad. So this is going to be 4.7819. Okay, so definitely expect something like that on the final. Okay, now number 7. Okay, the issue with this one is that it already has a log. So if it has a log, your goal is to get rid of the log. And maybe write this down somewhere. If you only have one logarithm in your entire equation, like this one, right? Then change it to exponential notation like we did right here up above. Okay, up to you how you do it. I'll do it both ways. So the thing I can do is take this little base and go a to the second power equals 16. How do you solve that for a? Take the square root of both sides, and you're going to get a equals plus or minus 4. Now, on this one, be really careful. A was actually your little base. Notice that it was your little base. Bases cannot be negative, so the only one that you're going to do here is a equals positive 4. So it'd be really sad to miss this problem because you put down plus or minus 4. Okay, so remember that bases have to be positive. Okay, for number 8, same idea. Okay, change to exponential notation. So you're going to have a to the third equals 25. And then how do you solve this? You're going to take the cube root of both sides. So cancel, cancel. And then cube root of 25, 2 ways you can do this on your calculator. You can hit the math button. So everybody hit the math button. It's right underneath the green alpha button. And then you scroll down to number 4. Okay, so math number 4 is your cube root. So you can do that, cube root of 25. And that equals 2.924. Now look, if you think that's going to be too hard for you to remember on the calculator, what's another way that you can write the cube root of 25? Well, I could write 25 to the 1/3. Remember, in over out, right? So you can just type that into your calculator as a 25 and then a caret and then parentheses 1/3. That's another way you could do it, okay? All right, number 9. Let me change color so it doesn't blend. Okay, again on this one, I don't have any logarithms. I don't know what 3 to the power of x equals 1.8. So I'm going to take the log of both sides. So log of 3 to the x equals the log of 1.8. Okay, fly those little guys down. So you're going to get x log 3 equals the log of 1.8. And then to solve for x, I'm just going to divide by log of 3, divide by log of 3. And you're going to get x equals, and then punch that into your calculator. Again, you guys, if you're doing this with me, really work on punching it in. You don't want to miss these questions because you don't know how to plug it into a calculator. So for this one, I got 0.535. I'll try to write a little bit neater. Okay, number 10, exactly same question. So hey, if you're like, I get number 9, why don't you pause the video and do number 10 and see if you get it right. So same thing, log of 4 to the x equals the log of 3. Okay, bring this little guy down. Oh, that's not a 4 though, it's an x. Let's try that again. So x log 4 equals the log of 3. Then I'm going to divide both sides by the log of 4, divide by the log of 4, and that's going to give me x equals, and let's plug that guy in, log of 3 divided by the log of 4. And for this one, I got 0.7924. Okay, notice you guys, sometimes I'm putting 4 decimals, sometimes I'm putting 3, just like whatever you want to do, I don't care. All right, number 11, 12, probably the easiest questions on the whole entire test. So for these guys, if your big base and your little base are the same, they cancel and you're just left with a 9. So can you predict, what do you think the answer to number 12 is going to be? Yay, it's 5, because big base and little base are the same, so they cancel out, so this is just going to be 5. Hey, if that's on your final exam, please don't miss it. Okay, number 13. So for this one, you want to use something called the change of base formula. And you might want to write this down so you have it. Change of base formula says that log base A of B equals the log of B over the log of A. And you guys, we actually proved this when I taught this a long time ago, like in January. Okay, so look back at your notes if you want to see the proof. Okay, but look, who does B represent? So B represents this little number, which is the 1.3, and then A represents the little base, so it's this one. Okay, so let's go ahead and plug this in. This would be the log of 1.3 all over the log of 4. So again, this is your B, this is your little A. And plugging that into the calculator, it's as simple as that. Log of 1.3 divided by the log of 4. And for that one, I got 0.1892. Okay, same idea for number 14. This is your B, this is your A. So it's the log of B, which is 2, over the log of A, which is 5. So plug that into your calculator. Log of 2 divided by the log of 5. And oops, I plugged it in wrong. Let's try that again. Log of 2 divided by the log of 5. Okay, it's 0.4306, something like that. Okay. All right, now these guys are super important because look, for these, you're not going to get a calculator. So this is the no calc section of your test. So the way your final is going to look is you're going to have some calculator questions, some no calculator questions. Miss Lee and I will let you know a little bit closer to the final, like how many on each, because we're still working on putting together the final. Okay, so if it's a no calculator section, if you see a log in your equation, like I do here, my goal is to get rid of the log. I don't want it in there, okay? So one way to do that is there's one log on the left and one log on the right, and the bases are exactly the same. Guess what? You can cross them out, okay? So you get x squared plus 36 equals 100. And then it's just a matter of solving the equation. So x squared equals, if I subtract 36, that's 64. And then if I take the square root of both sides, I get x equals plus or minus 8. Now, are they both going to work this time? You guys notice x is not a base anymore. The base is 10. So your answer can be negative, but you need to double check. This number right here, the x squared plus 36, has to be positive because the log of something must be positive, okay? That something has to be positive. So look, if I plug in a positive 8 squared is 64. 64 plus 36 is a positive number. So the 8 works. That's a good answer, okay? Now let's check the negative 8. If I plug in a negative 8 to this x squared, negative 8 squared is also positive 64. Plus 36 is going to be a negative 8. So that still works too, okay? So both of these work in this case because they both make that pink highlighted part of the logarithm positive. Okay, let's try number 16. Same idea. Got a log on the left, one log on the right. The bases are the same, so I can get rid of these guys. So this is going to be x squared plus 9x equals 10. Now, you guys remember any equation that has an x squared in it, that's not a highlighter. Gosh, that's really sad. Let's try that again. Okay, let's try again. Any equation that has an x squared in it is called a quadratic equation, right? Now, the way that we solve quadratics is to make them equal 0, and then we're going to factor. You cannot factor if it's not equal to 0. It's not going to work, okay? So how do I make this equal to 0? Well, let's subtract 10 from both sides. So I'm going to get x squared plus 9x minus 10 equals 0. Now this is big X factoring. So I want to find two numbers that multiply to give me -10 and add to give me 9. And that would be 10 and -1. So this is going to be x plus 10 times x minus 1 equals 0, which gives me that x has to equal -10 and x has to equal +1. Now again, let's double check this because both of them might work, or just one might work, or actually none of them might work. So if I plug in -10, remember this part right here has to be positive. So let's make sure it makes it positive. So if I plug in a -10, -10 squared plus 9 times -10. Is that a positive number? Well, let's try. That's going to be 100 minus 90. Oh, that's positive. That means -10 checks out. That is a good answer. Now let's plug in 1 into here, into the x's. 1 squared plus 9 times 1. Okay, that is definitely positive, right? So again, you guys, in this case, both of the answers worked. That's not always going to be the case, so make sure you double check them. All right, number 17. Okay, the mistake people make on this, they go, oh, log base 9, log base 9, log base 9. You cannot do that, okay? The reason why, that only works if there's one log on the left and one log on the right. I don't have that here. I have one log on the left, but I have two logs on the right. So if you have more than one log on either side, you need to condense, which means make it smaller, okay? So let's go ahead and condense this. This is log base 9 of x equals. Remember, you guys, this 1/2 flew down from this 144. This 1/3 flew down from that 8. So this is really log base 9 of 144 to the 1/2, sorry, minus log base 9 of 8 to the 1/3. Okay, now the question of the day is, what the heck does it mean to be raised to the 1/2 power? Let's write that on the side. So if you raise something to the 1/2 power, you're just taking the square root of it. If you're taking something to the 1/3 power, that means you're cube rooting it. Hey, you need to know this. If you're going to be in my AP Calculus class next year, this is a must know. Okay, so might as well learn it now so that you're not freaked out next year. Okay, so look, let's rewrite this. So I have log base 9 of x equals log base 9 of, now what is 144 to the 1/2. Remember, taking the 1/2 power means just taking the square root. The square root of 144 is 12. Okay, and then I have this minus log base 9 of, and again, 8 to the 1/3. Taking something to the 1/3 power is the same as cube rooting it, so the cube root of 8 is 2. Okay, now look, I made it prettier looking, but I still have 3 logs, so I have to keep condensing. So this is going to be log base 9 of x equals, now when you're subtracting, if you want to write this as one massive log base 9, if you're subtracting, that changes to a division. If you're adding, it changes to a multiplication. So what am I going to divide? This 12 and this 2. So let's put that over there. Now look, log on the left, log on the right. Now I can cancel them out because there's only one on each side. So I get x equals 12 over 2, or just x equals 6. Okay? All right, same idea for number 18. There is only one log on the left and one log on the right, but I can't cancel them out with these guys in front. I need to bring them back up to where they were before. So let's go ahead and do that. So this is log base 4 of x to the 1/2 equals log base 4 of 64 to the 1/3. Now there's one log on the left, one log on the right. So I'm left with x to the 1/2 equals 64 to the 1/3. Now what does that mean again? Remember, anything to the 1/2 power, that just means the square root of x. Anything to the 1/3 power means the cube root. So the cube root of 64 is 4. And then if I square both sides to get rid of that square root, I'm going to get x equals 16. And you guys, again, remember, this answer must make this number here positive. It does. If I plug in 16, it's still a positive number, so I'm good to go. Okay, number 19. Okay, so this one, interesting little guy here. Okay, so I have 2 logs on the left and no log on the right. That's interesting, but I still have to condense. So let's get these guys to write them as one massive log base 4. Okay, so what do I do here? If I see multiplication, if I see addition, that means when I condense, I'm going to change it to a multiplication. So this is log base 4 of x plus 2 times x minus 4 equals 2. Okay, and now look, if you only have one log, remember the cool little thing I wrote up here? Where was it? I don't even know where it is. There it is, okay? If you only have one log in your equation, change it to exponential form. So it's a harder version of number 7. So do I only have one log? I do. There's only one log in my equation, so let's change this to exponential form. So I'm going to start with my base. I'm going to raise it to the power of 2, and that's going to equal this little nightmare here on the right-hand side. So x plus 2 times x minus 4. And now it's just algebra, right? Let's solve this. So 4 squared is 16. If I FOIL this out, I'm going to get x squared, and then this is negative 4x plus 2x, which is negative 2x, and then that's going to be a minus 8. Remember, to solve a quadratic, you have to make it equal to 0. So let's subtract 16 from both sides. And that's going to give me a big fat 0 on the left, x squared minus 2x minus 24. And this is just the big x factoring. Let's do that on the side. So on the top, I have a negative 24. On the bottom, I have a negative 2. This will be negative 6 and 4. So this factors to x minus 6 times x plus 4. Now setting each of these factors equal to 0 is going to give me x equals 6 and x equals negative 4. Now the question of the day is, does it work? Well, remember again, let's highlight this. I want this part and this part to be positive. Okay, so if I plug these values in, if I plug in 6, 6 plus 2 is positive, 6 minus 4 is positive, x equals 6 is a good answer. But if I plug in negative 4 plus 2 is negative. Automatically, that's not going to work, so you can cross that one off. Okay, number 20 looks a little funny because you have different bases, a 10, and a 7. Don't panic because log base 7 of 7 equals a big fat 1, okay? So because I have two logs here, let's go ahead and condense. So I have log base 10 of, now I'm adding, that means when I condense, I'm going to multiply. So this is going to be, I don't need a big parenthesis like this. Let's try that again. So this is y minus 1 times y plus 2 equals a big fat 1. And now it's just like number 19. If there's only one log, change to exponential. So it's going to be 10 to the power of 1 equals y minus 1. It's going to be this right here, right? Times y plus 2. And exactly like number 19, go ahead and solve it. So 10 to the first is 10. If I FOIL this out, I get y squared. And then I get 2y minus 1y, which is just y. And then negative 1 times 2 is negative 2. Remember, with a quadratic, it has to equal 0. So let's subtract 10 from both sides. Then I have 0 equals y squared plus y minus 12. And let's go ahead and do a big X on this. So on the top, I'm going to have a negative 12. On the bottom, I'm going to have a positive 1, which is 4 and negative 3. So this is going to give you 0 equals y plus 4 times y minus 3. Setting both factors equal to 0 gives you y equals negative 4 and y equals 3. And again, you guys, don't do all this work and then miss it because you forgot to plug it back in. Remember, this part of your original function has to be negative. If I plug in negative 4 into there, negative 4 minus 1, that's a negative answer, so this one's bad. If I plug in 3 though, 3 minus 1 is positive, 3 plus 2 is positive, so y equals 3 should work, okay? All right, almost there, 3 more. Okay, number 21, this one's kind of gross. Actually, 4 more I like. Okay, take the log of both sides. So I'm going to have log of 5 to the x minus 1 equals the log of 3 to the x. And then I'm going to go ahead and bring down my exponents. This time I have 2 of them. So I'm going to have x minus 1 times the log of 5 equals x times the log of 3. Now, really up to you how you do it at this point. You can divide both sides by log 5 and just work with a decimal, or you can distribute. I'm going to opt for distributing because it gives me a more exact answer. So x times log 5 is x log 5. Negative 1 times log 5 is negative log 5. and that equals x log 3. Now you guys look, just like a regular equation, if you have x's on either side, you want them together. So you guys look, oh, that's not a highlighter again. And now I erased everything. It's okay. Log 5, sorry. Look, this has an x and this has an x in it. I want those two terms together, okay? So how do I get those two terms together? Well, maybe I can just take this guy and move it over to the here by subtracting. So I'm going to get x log 5 minus x log 3. Now look, they're together. That's what we wanted. But my other issue is that this one doesn't have an x in it, so I don't want that one there. So let's move that one to the other side. And how do I do that? By adding it. So that's going to be positive log 5. So I'm basically just switching the x log 3 and the log 5 by changing their signs. Now on the left-hand side, my goal is to solve for x. So because both of these terms have an x, I can factor it out. Then I'm left with log 5 minus log 3 equals the log of 5. And then if I want to solve for x, I basically just divide by all of this. So you're going to have log of 5 divided by, and make sure you put it in parentheses, log of 5 minus log of 3. The reason why we're putting it into parentheses is to make sure that your calculator divides by all of it and not just by part of it. Okay, so on the top, write this with me, log of 5, make sure you close your parenthesis, and then divided by, open a parenthesis, and you have log of 5 minus the log of 3. And you guys, for that one, I got that x equals 3.1506. I think that's what we got in class today too. All right, looking at number 22, same idea. Again, if you're like, ooh, let me try this one, like pause the video, see if you can get it right. So let's take the log of both sides. So I'm going to have the log of 7 to the x minus 2 equals the log of 5 to the x. Let's bring down our exponents, So you have x minus 2 times the log of 7 equals x times the log of 5. Okay, and I like to distribute, so let's go ahead and do that. Yikes, sorry. X times log 7 is x log 7. And then negative 2 times log 7 is negative 2 log 7. And then that equals x log 5. And notice, same issue as the last problem. I've got an x on the left and an x on the right, so they really want to be together. So let's just bring this one over by subtracting it. So you'll get x log 7 minus x log 5. And then the other issue I have is that this little guy, the negative 2 log 7, doesn't belong there because it doesn't have an x. So I'm going to kick that one to the other side by adding it, so that would be 2 log 7. Okay? Now again, because both of these terms have an x in it, I can factor it out, leaving me with log of 7 minus the log of 5, and that equals 2 log 7. And then by dividing, I'm going to get x equals 2 log 7, all divided by, make sure you put it into parentheses, log of 7 minus the log of 5. And plugging that into the calculator, do it with me, make sure you're getting it right. So I have 2 log 7, all divided by, parentheses, log of 7 minus the log of 5. And I got 11.5665. So let's write that down. So x equals 11.5665. Okay. All right, 2 more questions. And you guys, if you were absent yesterday, this is what we covered in class today, okay? So this one is going to be on the no calculator. Okay, so you might be like, well, how do I do that, Miss Cruzy? Okay, well, you don't cry. You just look at it and go, well, maybe I can get the bases to be the same. Wouldn't that be nice? So look, if I can get this base to equal that base, then I don't need logarithms, right? So how can I rewrite 1/4 as 4 to some power? Any ideas? Yeah, this stumped us today. Look, 4 to the negative 1 actually gives you 1/4. Remember, a negative exponent brings that base down into the bottom as a denominator. So I'm going to rewrite this as 4 to the negative 1, and then it's being raised to the x power, and leave this as a 4 to the x minus 8. Power to power, you multiply. So 4 to the negative x equals 4 to the x minus 8. And then once your bases are the same, you can throw them out. So what are you left with? Negative x equals x minus 8. And to solve that, I'm going to subtract x from both sides. So negative x minus x is negative 2x equals negative 8. And then if I divide by negative 2, I should get that x equals a lovely little 4. And then for number 24 on this one, same idea. I want to try to see if I can get these bases to be exactly the same. So let's rewrite the 1/3 as a, what do you guys think? Good job. This is 3 to the negative 1 to the x equals 3 to the x minus 6. Again, power to power, you multiply. Okay, this is like literally the same problem. This is kind of sad. Okay, once your bases are the same, you can get rid of them. So you have negative x equals x minus 6. If I subtract x from both sides, I'm going to get negative 2x equals negative 6. And then if I divide by negative 2, I should get that x equals 3. All right, so look, if you were sick today or if you were taking an AP test, this is how far we got on the final review. Tomorrow, because we have another huge AP test, I think I'm going to keep reviewing with you guys. I'm hoping that tomorrow, maybe we can get up to number 40. Wouldn't that be lovely? We'll see how far we get, okay? But you guys, a little bit at a time with this. This is exactly what your final looks like no surprises, all right? Hope you guys have a great day, and I'll see you tomorrow.